Salut à toutes et à tous, il y a quelques jours nous avons eu droit à une nouvelle vidéo sur MetaHuman qui était fort intéressante et qui nous expliquait un peu le but de MetaHuman, comment l'optimiser et quelques astuces pour corriger des problèmes sur Windows 7. Je vais vous en dire un peu plus dans l'analyse suivante et après mon analyse, vous allez retrouver la vidéo originale mais sous-titrée en français par mes soins. Je suis désolé pour les petites erreurs de temps en temps de traduction parce que c'est pas évident quand c'est technique, mais au moins vous pouvez bien comprendre ce que le responsable technique pour le projet MetaHuman a voulu dire. Donc cette vidéo a été enregistrée par le responsable technique de l'animation pour MetaHuman. Et en fait, dès le début, ce qu'il veut nous dire, c'est que le but d'Epic Games, c'est pas de faire un humain digital parfait. Ils savent très bien qu'ils sont attendus pour ça, Epic Games, mais ils disent tout de suite non, non, c'est pas ce qu'on veut faire. Nous, ce qu'on veut faire, et c'est un challenge, on veut donner aux gens la possibilité de faire un humain digital facilement et gratuitement, et que ça fonctionne sur tout support, aussi bien les consoles dernière génération que les PC, que les téléphones. Et on peut imaginer que c'est un sacré challenge quand même, puisque c'est pas du tout la même puissance. Et donc il a bien insisté là-dessus. Et d'ailleurs, ce qu'il fait ensuite dans la vidéo, il montre comment optimiser les performances. Vous pouvez voir le nombre de FPS qui s'affiche. Ensuite, dans le niveau de détail, donc le level of detail, vous voyez bien que vous pouvez choisir entre 0 et 7 niveaux de détail. Et que c'est plus ou moins net. Surtout, ça se reporte la netteté, surtout par exemple sur les sourcils, les cils et les cheveux. Voilà, mais il explique tout ça dans la vidéo. Et ce qu'il dit aussi, c'est que en faisant un réglage facile comme ça, vous modifiez le niveau de détail. Mais il dit par contre que ça va impacter une centaine de paramètres en tâche de fond. Voilà. Et en fait, il veut faire comprendre que c'est ça la difficulté, c'est qu'il y a beaucoup de paramètres qui vont être impactés et qu'ils ont essayé malgré tout, même quand on met le niveau de détail à 0, quoi, le plus petit possible, de garder quand même une bonne qualité, en fait, un bon rendu. Et on peut s'en apercevoir quand on fait des tests avec la démo qui a été fournie de MetaHuman. Et je pense que c'est assez impressionnant et ils vont plancher là-dessus avant la sortie officielle de MetaHuman, c'est ce qu'il dit. Il donne aussi des astuces pour pouvoir utiliser la démo de MetaHuman quand vous avez Windows 7 et que vous n'avez pas DirectX 12. Voilà, donc c'est une petite info qui est, je trouve, bien utile, je pense. Et il explique aussi, quand vous lancez la démo de MetaHuman, c'est par défaut, il y a le ray tracing qui est activé. Donc il vous explique comment le désactiver. Ça nécessite un redémarrage de l'Unreal Engine. Et ça peut être un peu long parce qu'il faut qu'il recalcule les shaders. Voilà. Donc c'est une vidéo intéressante qui explique vraiment le but de MetaHuman, les difficultés qu'ils ont aussi à faire ça, et comment optimiser MetaHuman quand on va vouloir l'utiliser sur Unreal Engine. Donc c'est une vidéo plutôt sympa que je vous laisse regarder maintenant. N'hésitez pas à mettre un j'aime pour m'encourager parce que la traduction ça a été un peu galère à faire et un peu long. Mais je pense que c'est bien comme ça pour de l'avoir aussi, d'avoir les sous-titres en français. Et que c'était une vidéo quand même intéressante. Portez-vous bien, à plus plus.
Hi, my name is Christopher Evans, and I am the lead technical animator on the Digital Humans team here at Epic Games. I wanted to take a couple minutes today to go over some of the hardware settings in Unreal Engine and some of the new features that allow MetaHumans to really work well on different hardware platforms. So, from kind of day one with MetaHumans, the goal was to not just make really high fidelity digital humans that kind of everybody expects from Epic, but kind of enable anybody to make that, kind of democratize the creation of that, but also allow them to run on multiple hardware platforms and really make usable characters that can be used in games and have all of the features that a AAA game studio or an indie game studio expects in order to use those characters in a real-time application, whether it be on a virtual production stage, or on a Switch or an Android device. So that's a really tall order. I don't know of anybody that's really done that before. It means getting the same assets working with levels of detail across many different hardware devices. So the MetaHumans have 8 levels of detail, and you can kind of walk through those different levels of detail depending on your current context. So the kind of easiest way to do that is to go up here and tweak the engine scalability settings. This is kind of analogous to in a video game where you kind of set different rendering characteristics based upon how beefy your PC is or whatever. For those of you who aren't aware, you can type stat space FPS down here in the output log, and this will kind of tell you what the current frame rate is. If you're not sure where the output log is, you can go down to Window, Developer Tools, Output Log. And I've always got the output log open here on a tab just so I can kind of see what's going on. I'll refer back to it later. You can get quite a bit of feedback about what's happening with the engine and stuff from down there. So if I go to the settings, engine scalability settings, I can walk from low to high to medium to epic to cinematic. And as I'm clicking these, you can see the image changing in the background, but you can also see all of these different CVARs being set that are changing different features in the engine. They're turning off, hundreds of different features in the engine and changing different scalability settings in the engine. So, you can see how it kind of affects the frame rate, but it also, you can see all of those different CVARs that are being changed under the hood. So, with all of these different LODs that I had mentioned, one thing I wanted to talk about is a new feature called the LOD sync component. And if you select the character's blueprint here, you'll see this LOD sync down here. And there's a lot of different components syncing and a lot of different custom LOD mappings and things. But the TLDR here for this feature is that in order to make really high fidelity human characters and have them kind of walk right up to you in a game or in a cinematic, and then the cinematic is over and you're right back into the game, right back into the story, or whether it's virtual reality or some kind of live experience, in order to have characters look the best they can, you have to be able to turn off certain features as they recede away into the distance. So the LOD sync component, what it does is it essentially creates different buckets, and you can sync many different parameters and meshes across different LOD levels. So here you see that it says we have 8 LODs. That's because the head, which drives a lot of the LODing, it has 8 levels of detail. The body has 4 levels of detail. And what the LOD sync component can do is it can say like, hey, every 2 levels of detail of the head, I want to change 1 level of detail of the body. And why that's important is because when you're changing mesh levels of detail and there's seams involved, you really want to make sure that you always have, head level of detail 2 with body level of detail 1 or whatnot, because you need the vertices to line up, the skin weights to line up, the blend shapes to line up. Why I'm also pointing this out is, let's say that you're on a virtual production stage or you are kind of game location scouting, or you are making, you're doing a layout pass and you're dropping a lot of different characters into the level. You can go ahead and you can force the LOD sync component to be like LOD 4. And as you saw, the face, the vertices and geometry on the face got a bit faceted. The hair is now a card representation and not a strand representation. But, now the character is a lot more performant and you can drop a lot more down. You can LOD all the way down to level 7, and it's, and there's 8 levels, but it's 0 index, so it's 0 through 7. And as you navigate the LOD levels, we are dropping like joints, 100 different poses of anatomical joints that keep volume on the character, and certain rigging, shaders, and different, the strand-based hair to card-based hair. There's a lot of different, it's not just geometric complexity. There are a lot of settings that are associated with these different buckets, if you will. If I set this back to -1, that means I want it to be automatic. And with it on -1, I can go in and you can see exactly when the hair pops to a card representation. The hair strands are not actually polygonal, so they don't right now render when we go to wireframe view. They're actually real strands on the GPU, which is pretty awesome. So that is the LOD-sync component. And while I'm on hair strands, I wanted to mention there is a CVAR that even in LOD 0, you can go ahead and disable hair strands. And you saw that little pop. And what this did is it blended to a card version of LOD 0 hair. We understand that even on some current gen consoles, having multiple characters on screen with very, very like feature film fidelity hair, it can be taxing on a GPU if you're doing other operations like have AI or physics running. So we are shipping MetaHumans with a LOD 0 set of card hair, and that's what you see here. I can go back and I will turn on the wireframe again. So this is the high fidelity hair cards. I will mention that when you're in this mode right now, it appears like the lashes are gone. The lashes are actually there. It's just when you pop into the game's not evaluating right now. As soon as the game is evaluating, you see that they popped on. So that's a setting that if you never wanted to have strand hair and you always had strands disabled, you could put that in your any file and you could set the shader to always be there. We have to manage that shader relationship because when the strands are rendering, we don't want you to see the card-based eyelashes. But they are there, and that's how you can turn them on. I'm going to go ahead and turn the hair strands back on. So one other thing would be ray tracing. Let's say that you don't feel that you need ray tracing, you have DirectX 12, but you can go into the project settings, and up here if you just search for ray tracing, you can disable ray tracing, and that is going to require an engine restart, but already your character should be quite a bit more performant if you disable ray tracing in this scene. One of the last things I wanted to touch on would be DirectX 12 versus DirectX 11. Now, some people were having issues where they have Windows 7 and they don't have access to DirectX 12. So you can go into your project settings, and if we go down to Platforms Windows, we can set the default RHI, and I can set that to DirectX 11. And now when I restart the engine, I'm going to start in a DirectX 11 mode. RHI, I believe, is the rendering hardware interface. I'm not a graphics guy. I'm not a graphics engineer, but if you just wanted to know. So I'm going to leave it in DirectX 12 right now. And the way to query that, you can type r.rhi dot, and there's only one CVAR left, it's name. And if I query that, it tells me I am in D3D12 hardware interface right now. So you're on Windows 7 and you can't even load the engine because it requires being loaded in DirectX 12 in order to set it to DirectX 11. That can be, that's a challenge. So I'm going to show you how to kind of go into the project. So here's the project folder. It's going to be in your Unreal Projects folder, MetaHumans config. Then there is a default engine.ini file. You can search in here and find default graphics RHI. That is the project setting that we had just changed. If you go ahead and just delete that, save the file, that's going to set you back to default. And what default actually is DirectX 11. So if I close out the engine and I reload that project, we will again query the RHI name, and I believe it will be running in DirectX 11 mode. So CVARs are persistent across sessions, which is awesome. So if I query the RHI name, you see it's D3D11. So that is how you can load up the project if you don't have access to DirectX 12. And you know, the stuff still looks pretty high fidelity. DirectX 11, you just won't have access to some of those DirectX 12 features. And if you are just mousing around the demo and you didn't know, you can press G, and G removes those game meshes. So that's about it. I briefly went over all the different scalability settings, all of the LOD levels, how LOD sync works, how you can use force LOD to drop a bunch of different metahumans into the level. If you're a AAA developer, really look at LodSync. LodSync is really awesome. It was developed by Lena Halper here at Epic, and it really allows you to make the highest quality characters that you can on any given hardware that you're on. But you'll also see how we use it to drive different LOD levels. The characters have very complex rigging and different things that kind of slough off as the character walks away. On the face and the body. So then we talked about how to disable the hair strands, and that there is a LOD 0 representation of cards that's in there, and how to disable ray tracing, how to go to DirectX 11 RHI mode, and how to kind of boot the engine into DirectX 11 if you can't open it on your current hardware platform. So as I said, it was very important to us that these characters can scale and be used in many different situations. You know, this is about you all telling your stories. We can't even come up with the different situations that you're going to want to be using metahumans in. We're really looking for your feedback when it comes to those different hardware platforms. And from now till release, we're really going to be working to try to get the characters looking as best as they can, regardless of which hardware platforms they're running on. But that's a real challenge because, you know, we're not going to make characters specifically just for a particular hardware platform. The goal is to make scalable characters that work on a wide kind of a range of array of hardware platforms. But thanks for taking the time to listen to me ramble on, and we really hope that you guys are enjoying this sample of MetaHumans and can't wait to see what people do with the tools once we release them later this year. Thanks a lot. Bye.